Hi students, welcome to today's class. Today I am going to explain very important problems on differentiability. So these differentiability problems based on they are very theoretical problems they are. Okay now, so they will be asked in your JEE mains examination. So let us see that problem. So such a type of one important problem is discuss the differentiability of f of x is equal to, it is a function defined as, when x is not equal to 0, the function is defined as x into sine of log x square to the base c. If x is equal to 0, the function is defined as f of x is equal to 0. So this is the differentiability. Now we have to check at x is equal to 0, the function is differentiable or not. That means at x is equal to 0, that means so this is x-axis and it is a y-axis. At here at x is equal to 0. So the graph of this function, let it the graph of this function here, or we can able to draw the tangent or not. That is the main thing. Differentiable means what? Are we able to draw a tangent at x is equal to 0 for the curve given by this function? That is the main thing. So to check that, we cannot draw the graph at a time, but we will approach it theoretically. So before checking the differentiability at x is equal to 0, we have to check the continuity at x is equal to 0. At x is equal to 0, if the function is continuous, then only we have to check whether it is a differentiable or not. If it is not continuous, definitely it is not differentiable. That means there is a break will be there. So now first we have to check the continuity at x is equal to 0. Solution: continuity at x is equal to 0. We have to check continuity at x is equal to 0. Let us check the continuity. So to check the continuity, so we have limit extends to 0, f of x is equal to f of 0 we have to get. Understand? If you show that, the problem is over. So f of 0 is equal to how much? When x is equal to 0, f of 0 is equal to how much? 0. Understand? So now find out limit extends to 0, f of x is equal to how much? X sine of log x square to the base c. Okay now, let us find out this value, whether we will get this value as 0 or not. Okay now. Now let us separate the limit for both the things, x into limit extends to 0 sine of log x square to the base c. Okay now, right. This is a limit extends to 0 into x is equal to how much? This is a 0 into whatever may be the value, limit extends to 0. So if you treat this as a log x square to the base as a y, let it call it as a y, as x value approaches to 0, y value approaches to minus infinity. That means what? Limit y tends to minus infinity sin y. So it is a finite value which lies between minus 1 and plus 1. It is a finite value. That means what? 0 into a finite value which lies between minus 1 and 1. Okay now? Right. Therefore, you will get an answer 0. So limit extends to 0, f of x is equal to f of 0, we got it. Therefore, at x is equal to 0, the function is continuous. Now let us check the differentiability. Okay now? So that means left hand side derivative is equal to right hand side derivative, we have to show that. So let us continue the solution. We have checked the continuity of this function at x is equal to 0. The function is continuous at x is equal to 0, we proved. Now let us check the differentiability. Differentiability of this function. Okay, differentiability at x is equal to 0. Let us find out left hand side derivative at x is equal to 0. Left hand side derivative, right hand side derivative, whatever may be, you can find out left hand side or right hand side. That means what? That means we have to find out f dash of 0 plus s. So let us find the first write the derivation of f dash of a plus is equal to limit h tends to 0 f of x plus h minus f of x by h. Okay, now that means f of x plus h minus f of h. F of x plus h minus f of h by h. Okay, now right. So we are finding the right hand side derivative at 0 plus wherever here sorry a plus h this is. So f of a plus h minus f of a, this is the formula, f of a plus h minus f of a by h. Right, at 0 plus we are checking. Limit h tends to 0 f of 0 plus h minus f of 0 whole divided by h. Understand this? So that means limit h tends to 0 f of h minus f of 0 by h, that is the value we have to find out. So this is equal to limit h tends to 0 f of h. F of h means what? H into sine of log of h square to the base e minus f of 0. Actually it is not 0, h value approaches to 0. Okay, now so 0 into some f of 0, already it is given that f of when x is equal to 0, f of 0 is equal to how much? 0. When x is equal to 0, f of 0 is equal to 0 by h. Okay, now right, h. Any more cancellations? H will get cancelled. So this is equal to limit h tends to 0 sine of log of h square to the base e. In the previous when continuity we explained, this value lies between minus 1 and 1. This value lies between minus 1 and 1. Okay, now that means what? Right hand side derivative is not fixed one. RHAD is not fixed or not finite. It is not finite, but it lies between minus and 1. So it is oscillating between minus 1 and 1. So therefore, right hand side is derivative is not fixed. Therefore, at x is equal to 0, f of the given is not differentiable. We cannot differentiable. That means at x is equal to 0, even though it is a continuous function at x is equal to 0, we cannot draw a tangent at x is equal to 0. That why, because here the right hand side derivative came, the answer lies between minus 1 and 1 plus 1. So it is not a fixed one. That's why, so the function this is not differentiable at x is equal to 0. So I hope that you understand this solution. Let us move to next problem. Welcome to this second problem. So this is a very theoretical question. Discuss the differentiability of the function that is at x is equal to e. The function is defined as at x is not equal to e. The function is defined as, so I am writing very clearly. So f of x is equal to x minus e into 2 to the power of minus 2 to the power of 1 by e minus x. See the function. See the function, how the function is defined as f of x is equal to x minus e into 2 to the power of minus 2 to the power of 1 by e minus x. Okay, now, so this is the function. We have to discuss the differentiability at x is equal to e. So before that, for every differentiability problem, we have to check the continuity at x is equal to that particular point. Why? Because if it is a continuous, then only it is differentiable. Okay, now right. Check the continuity at x is equal to, right. So continuity at x is equal to e. Okay. So that means what have to prove? So limit x tends to e. So limit as x tends to e, f of x is equal to f of e. That we have to check it. Limit x tends to e, f of x is equal to f of e. So f of e is equal to how much? See here, x is equal to e. F of e is equal to how much? 0 you have to get. Limit x tends to e, f of x is equal to f of e. To find out this, so we have to check the both left hand side derivative and right hand side derivative we have to check. Okay, now. So here for left hand side and right hand side, so both same condition it is defined. So for x less than e and x greater than e, both conditions are same. That's why we can directly find out limit x tends to e. Otherwise, if it is required, you can find out both left hand side LHL and RHL, left hand side limit and right hand side limit, both you can find out, no problem. So f of x is equal to x minus e into 2 to the power of minus 2 whole to the power of 1 by e minus x. Okay, now let us see here, separate it, limit x tends to e x minus e into limit x tends to e 2 to the power of minus 2 whole to the power of e minus x. Okay, now let us see here, as x value approaches to e, x minus e approaches to 0. It is very clear 0. But always remember that, don't write down if it is a 0, therefore answer is 0. No, 0 into one certain finite value, okay na? Either it should be 1, 2, 3 or root 2, root 3 minus 1 by 2, 6 by 5, 7, certain finite value you have to get. If you get say infinity or the type of value, so 0 into infinity, it is not 0. Understand this? That's why. So first of all, you have to check the value of this. See here, as x value approaches to e, so here e minus x value approaches to 0, e minus x value approaches to 0. See here, e minus x value approaches to 0. So therefore 1 by e minus x value approaches to infinity. So therefore minus 2 to the power of infinity, that means what, minus 2 to the power of infinity, that is a 2 to the power of minus 2 to the power of minus 2 to the power of infinity we are getting. That means what, 1 by 2 to the power of, we can write it as a to the power of minus a, that means 2 to the power of infinity we will get. On the whole, 2 to the power of infinity approaches to 0, 2 power 0, 1. So therefore you will get 1 here. So this value is equal to 1, 0 into 1. Understand this? So you will get a 0 to 1 as a x value. See here, this minus 2 whole to the power of infinity you are getting, minus 2 whole to the power of infinity. So this value, as a x value approaches to 0, so that value approaches to 1. So therefore 0 into 1 is equal to how much? 0. That means we got 0. Therefore this function is a continuous at x is equal to e. Okay, now therefore let us check the differentiability of this function at x is equal to e. Okay, now welcome to the remaining problem. Let us check the differentiability of this function at x is equal to a. So at x is equal to a, find out both the right hand side derivative and left hand side derivative. So first we will find out the right hand side derivative, that is a f dash of a plus is equal to limit h tends to 0 f of a plus h minus f of a by h. So this is the formula. So f dash of e here, so what you are finding at x, where you are finding x is equal to e. So therefore e plus right hand side, that means what, limit h tends to 0 f of e plus h minus f of e by h. Okay, right. That is equal to limit h tends to 0, f of e value is equal to how much? At x is equal to e, f of x value is 0, therefore f of e value is 0. So this value is f of e plus h by h. Okay, limit h tends to 0, f of e plus h by h. So let us find out this value. So this is equal to limit h tends to 0, f of e plus h means what, wherever x is there, substitute e plus h. Substitute here in place of x, e plus h minus e into 2 to the power of minus 2 to the power of 1 by e minus x. X means e plus h whole divided by h is there. Any more cancellations? Let us see here. Plus e minus e cancel. H also you can cancel. Why? Because as h value approaches to 0, h is not equal to 0. Here also plus e minus e also cancel. So here ultimately what remains? Limit h tends to 0, 2 to the power of minus 2 to the power of 1 by minus h. 2 to the power of minus 2 to the power of 1 by minus h. Here as h value 0, minus 1 by h value tends to infinity, minus 2 whole to the power of minus infinity means 1 by 2 to the power of infinity, 0, 1 by 0. So it approaches to 0, total this power approaches to 0, 2 power 0, 1. So same explanation we given at continuity, okay now. So this value is equal to 1. Therefore right hand side derivative value we got 1. Right hand side derivative value we got 1. Let us find out the left hand side derivative at x is equal to e. Okay, welcome to the differentiability at x is equal to c. We are going to find out left hand side derivative at x is equal to e. The formula is f dash of a minus is equal to limit h tends to 0, f of a minus h minus f of a by minus h. So this is the left hand side derivative. Okay. So we are checking at f dash of e minus, that means limit h tends to 0, f of wherever a is there, e minus h minus f of e by minus h. Okay, right. F of e value is equal to how much? F of e value is 0. At x is equal to 0, f of e value is 0. So this f of e value will become 0. Limit h tends to 0, f of e minus h by minus h. F of this value will become 0. This is 0. Now let us find out the value of f of e minus h. So this is equal to limit h tends to 0, f of e minus h. Wherever x is there, substitute e minus h. So this is equal to e minus h in place of x, e minus h minus e into 2 to the power of minus 2 whole to the power of e minus x value is equal to how much? E minus h. E minus h whole divided by minus h. Whole divided by minus h. Now any more cancellations? See here. Plus e minus e cancel. Minus h cancel. Why? Because as h value approaches to 0, h is not equal to 0. Here also plus e minus e cancel. Ultimately what remains? Limit h tends to 0, 2 to the power of minus 2 to the power of 1 by h divided by nothing. So that's all. 2 to the power of minus 2 to the power of 1 by h. See here, as h value approaches to 0, h value approaches to 0, 1 by h value approaches to infinity. So this approaches to infinity. 2 to the power of minus 2 to the power of infinity. That means what? 2 to the power of minus 2 to the power of infinity. That means 1 by 2 to the power of 2 to the power of infinity. That means what? Denominator is going on increasing. Denominator is going on increasing. Therefore, its value will become 0. So therefore, left hand side derivative is equal to how much we got? 0. Whereas right hand side derivative is 1, left hand side derivative is 0. Therefore, it is not, even though it is continuous at x is equal to e, the function is not differentiable at x is equal to e. So this is one of the very peculiar problems. So completely based on the definition only you have to do. Okay. So I hope that you understand this theoretical question. So let us move to next problem. Hi students, welcome to this problem. So discuss the differentiability of this function at x is equal to 0. So the function is very clear. F of x is equal to root of 1 minus x square at x is equal to 0. So first we have to check the continuity of the function. Continuity of this function f of x at x is equal to 0. So clearly, so we know that clearly it is a continuous function. Why? Because we find out limit x tends to 0 f of x value. Limit x tends to 0, f of x is given root of 1 minus x square. limit x tends to 0, root of 1 minus root of 1 minus x square. Substitute x is equal to 0, 1 minus 0, 1, root 1, 1, 1 minus 1, 0. This is equal to 0, which is same as f of 0. Okay, now? Therefore, this is a continuous at x is equal to 0. Let us check the differentiability at x is equal to 0. Second one is what? Differentiability at x is equal to 0. Okay, now. So, for differentiability, we have to find out right hand side derivative, left hand side derivative. First, I will write down the formula. Right hand side derivative is equal to f dash of a plus, this is equal to given by limit h tends to 0, f of a plus h minus f of a by h. Okay, now? Okay, now. Now, we are finding at where x is equal to a, x is equal to 0. That means what? F dash of 0 plus limit h tends to 0, f of a 0 plus h, f of h minus f of 0 by h. That is limit h tends to 0. F of 0 is equal to how much? 0. So, this value is 0, no problem. Now, f of h value root over 1 minus root of 1 minus h square divided by h. Now, you have to find out the limit of this value. Okay, then how to find out? So, let us multiply the numerator and the denominator with the root of 1 minus root of 1 minus h square plus root of 1 plus root of 1 minus h square. Multiply the numerator and denominator with that value. Okay, so let us see what happens. So, this is equal to limit h tends to 0. 0 means actually 0 plus here. To be frankly speaking, 0 plus. Okay, now, right. See here root of, so here a plus b into a minus b, a plus b into a minus b, a square minus b square, root of a square minus b square whole divided by h into root of 1 plus root of 1 minus h square. Okay, now, right. So, any more cancellations? Right, here if you see here, plus 1 minus 1 cancel, root of h square. Root of h square actually mod h will come. Root of h square mod h come. But here you are approaching h. H value approaches to the right side. From right side means what? H greater than 0. Therefore, mod h value you have to take h. So, okay, na? So, this whole thing we will get h. H will get cancelled. H will get cancelled. So, therefore, limit h tends to 0, 1 by root of 1 plus root of 1 minus h square. Now, substitute here wherever h is equal to 0, substitute here. So, this is 0, 1 minus 0, 1, 1 plus 1, 1, 1 by root 2 we are getting. So, right hand side derivative we are getting 1 by root 2. Let us find out the left hand side derivative. Okay. Welcome back. Let us find out the left hand side derivative at x is equal to 0. So, I will write down the definition. Left hand side derivative f dash of a minus is equal to limit h tends to 0, f of a minus h minus f of a by minus h. Okay, now, so this is a left hand side derivative. That means what? F dash of 0 minus is equal to limit h tends to 0, f of 0 minus h minus f of 0 by minus h. Limit h tends to 0, f of minus h minus f of 0. F of 0 already it is 0. So, this is 0 by minus h. Okay, now wherever h is there, substitute minus h. So, we will get here limit h tends to 0. The formula is a root of 1 minus root of 1 minus. In place of x substitute minus h. Therefore, h square divided by minus h. Just like in the previous problem, multiply the numerator denominator with 1 plus root of 1 minus h square by root of 1 plus root of 1 minus h square. So, this is equal to, we will get limit h tends to 0. So, this is a 1 minus root of 1 minus h square. So, plus 1 minus 1 will cancel, root of h square. So, root of h square is equal to how much here? How much you will get root modulus of h. So modulus of h is equal to how much here? As h value approaches to 0 and plus h will come, so that h will get cancelled, and again we will get how much here? Ultimately we will get minus 1 by root 2 we will get. Understand this? We will get minus 1 by root 2. So right hand side derivative is a 1 by root 2 and the left hand side derivative is equal to minus 1 by root 2. So f of minus h, wherever x is there, substitute minus h whole square means h square, okay, divided by minus h, minus 1 by root 2 we will get. Understand this? Minus 1 by root 2. Up to here without minus we got 1 by root 2. Now we will get minus 1 by root 2. So all LHD is equal to minus 1 by root 2. Since right hand side derivative, left hand side both exist, but they are not equal. They are not equal. Therefore, the limit, therefore, the function is not differentiable at x is equal to 0. That means what? At x is equal to 0, you will get a sharp edge. That's why we got it. Okay. So I hope that you enjoyed today's these problems, and some more problems tomorrow's class I will stand before you. So until then, all the best.